So we actually do tend to think of Ireland as like our soft-eyed, sad-eyed mother, who was always taking care of us somewhere in the background. I come from right there, okay, which is in the province of Munster. Okay, so I'm a Munster man. Any rugby fans here? No rugby fans? Okay, so you have a Munster. If you do happen to go to Ireland, you're probably going to fly into one of two airports. This is Dublin Airport, that's the capital of Ireland. But this is the one that I fly to, which is Shannon Airport in the Midwest. And just to give you an idea of what the scale is like, that drive from the airport to where I grew up is about an hour and 15 minutes. Okay? So you could actually drive from the tip of Ireland down to the southernmost point probably in about 7 hours, and the road system has improved so much. We were just talking about that right now. Has improved so much that it's actually possible to do it. You could make it in about 7 hours. And nobody's going to be able to pronounce that correctly. It's very non-phonetic. The name of that town that I grew up in, or parish I grew up in, is called Athea. So I'm showing you this picture for a very good reason. Okay, so this is Ireland circa 1970. Okay, so a couple of things you'll notice. One is that roofing material, that's called thatch. Yes, I grew up in a thatched cottage, and it's basically a coarse form of grass, right? And so that house that I grew up in was 250 years old when we left it, and it was built by peasant farmers in the west of Ireland, from which I am descended. And they built it out of whatever was available, okay? Talk about a feat of engineering. You guys are engineers. They made do with whatever. They dug stones out of fields. They chopped down trees, and they cut grass, and they built a house that lasted 250 years. The way that it came down, by the way, is because it was covered with thatch. Thatch is, like I say, a coarse grass, which is a great roofing material, provided there's a fire in the house, provided there's a heat source within the house. As soon as you take away the heat source, that grass absorbs about 10 times its own weight in water. And so as soon as we abandoned the house, the rafters got crushed. The walls are still standing, and they'll be standing long after I'm dead. Okay? But just to point out a few things, that's me now, approximately today, maybe a couple of years ago. Anybody want to take a shot and see? That's actually me when I was about 7 years old. Okay, looks like I have a kind of a defined fear of direct sunlight. Okay, so what this story is about, really, the story that I'm trying to tell you, is how I got from there to there. I mentioned a couple of things in passing. This is my dog Tiger. Okay, long since gone, of course. The most intelligent creature that has ever inhabited this planet, and I'm including human beings. This animal could read your mind. Okay. And by the way, I don't know how many times we took family photographs, and we'd look in the background and we'd say, is that Tiger? He had a way of getting into every single photograph that was ever taken. By the way, the reason why the photograph was taken is because this woman was visiting Ireland. She was actually living in Connecticut at the time. That's my first cousin, okay? So the history of immigration of Irish people all around the world was continued through her and then later through me. And then a little bit of controversy here. If you look really closely, you'll see that I have something, a ball of something in my hand. Anybody want to take a wild guess what that is? It's hemp. Hemp, right? And so what hemp was used for in Ireland at the time was for harvesting hay, which was how you fed cattle over the winter. You had to go out in a very manual way, cut the hay, save it, dry it, put it into piles. But the thing that you kept the piles on the ground with so that they didn't get blown away was hemp. So here I am, a 7-year-old boy with my ball of hemp. Okay. So that's it. So a little bit more about who I am. I'm going to go through this really fast. You know, I always said I have two kind of lives. I have a real life and a vicarious life. Does anybody know what vicarious means? Hands up, come on guys, this should be interactive. What's a vicarious?
Live through somebody else.
That's right, live your life through somebody else's experiences. That's exactly right. So this is my real life. That's me on my honeymoon. That's my darling wife beside me, where I'm actually pulling a pint of Guinness in what used to be my father's favourite pub. Okay, I'm Irish, yes I drink. Okay, therefore I am. I used to be a runner. I used to be a reasonable facsimile of a runner. Okay, nature has kind of taken over that. Life has kind of given me other ideas. But believe it or not, that's me during my fitter days, and that time up there I wrote in, that was my mile time. I ran an indoor mile over the age of 40. I was actually nearly 45 years old at 4:44.53, right? Just to give you a reference point, I got on the treadmill a couple of days ago, and I just made it under 7 minutes. So life has other ideas, and I like doing outdoor stuff. This is me skiing in Pennsylvania. So that's my real life. That's the stuff that I like to do. Then there's the vicarious life. Anybody in the audience who recognize that picture? Yes? No, it's not. It's not. It's actually soccer. Okay? So this is the 1999 European Champions League final, okay, between Manchester United and Bayern Munich. And that's the moment when they pulled off the biggest recovery, the most unbelievable comeback in the history of the sport. They were 1 goal down when the game was effectively over, when they scored 2 goals in time added on. And anybody want to take a guess what this sport is? Rugby. I already mentioned it. So this is another wonderful moment in my life when this young man, Tommy Bowe, since retired, went over the line to score Ireland's second touchdown, really known as a try. Okay, and they beat the Springboks. Anybody know who the Springboks are? South Africa, probably the strongest or second strongest rugby nation on the planet. The Irish beat them in Dublin. Needless to say, after that try, I was probably transported about 6 feet in the air, and a sound came out of me that I could never duplicate. Okay, so that's my vicarious life. Okay, so that's just me. Okay, so let's just move on. I wanted to focus on the whole idea of a capstone and what it can actually mean in your career. And I brought a few props. Okay, so I went to the University of Limerick in Ireland, and everybody had to do a capstone. That's my capstone report, okay? So that's what I had to submit after 3 trimesters. It was a trimester system at the time, okay? So that's what I had to submit. And the title is, if I get to the right page here, Environmental Resistance of Carbon Fiber Reinforced Polyether Ether Ketone. I'm a material scientist and manufacturing engineer. That's my background. So I don't know anything about this electrical stuff. Ohm's who? Kirchhoff's what? You know? I'm kidding, of course, but that really has not been my focus. But that's my senior design, okay? This is my PhD thesis, okay? Remember what I told you the title of my senior design was? Well, the title of my PhD thesis was The Effective Environment on the Flexible Fatigue Properties of Carbon Fiber Reinforced Polyether Ether Ketone, okay? I'm standing before you with a PhD as the Associate Dean of a school, of a college, I should say, because I did a capstone project. And everything else is what led to that, right? So if you don't think what you've just been through is significant, you're wrong. It actually could be transformative, and actually should be transformative in your career, because it's where you bring everything together, okay? So I just wanted to show you those. So there was my senior design project. This is my PhD project, and that's what that led to. Now I'm the Associate Dean of STEM at Youngstown State University. What comes next? The President of the Known Universe. That's my fiendish plan. But the point is that one thing leads to another, right? And as you go through this experience that we call a career, all sorts of wonderful things can happen to you if you just keep your eyes open and you just connect with other people and you connect with other disciplines. Don't ever get pigeonholed. Don't ever get stovepiped. Okay, learn about what other people do as well. I'm sure you're excellent in the qualification that you're about to get, okay? But broaden your horizons always, okay? So what happened? Well, I got my bachelor's degree. Then I went to the Massachusetts Institute of Technology. I want to tell you a little bit of a story about that. So, MIT, what the heck is this guy from the west of Ireland doing at the Massachusetts Institute of Technology? This is nuts. So I just got my PhD, I literally got off the plane, and I thought, what am I going to do now? I have this PhD, I have no idea what to do with it. Okay? So I went to the Massachusetts Institute of Technology and I started knocking on doors. Doors of people who were roughly in the area that I published my thesis in, right? So I knocked on the door of one full professor, and he told me many years later He said, when I saw you outside my office door, I had one priority and one priority only: to get rid of you as quickly as possible. Right? That's what he told me. He was just coming back off of sabbatical. He had 1,000,001 things waiting for him to do, right? And then he said, I just got to get rid of this guy with the weird accent. Okay? 45 minutes later, he offered me a job. Okay? And I started working as a postdoc at MIT. About a year later, I was promoted to the permanent research staff. I was never on tenure track. The permanent research staff as a research engineer, just because I was willing to knock on a door. Okay? It was wonderful. I mean, everything you've ever heard about MIT as a place to work is absolutely true. Yeah, it's like the janitors are talking about thermonuclear physics, right? It really is a rarefied atmosphere. But it's a wonderful place to be, and it just shows you what can happen if you just dare. I work with a small company in Girard, Pennsylvania, as a senior development engineer, and then I got probably the most exalted title of my entire career. I was principal engineer of advanced development at Northrop Grumman, now the world's second largest defense contractor. At the time, it was right on the cusp of being number one. And I'll show you some of the stuff that I did there. I went to Penn State University after that to the Applied Research Laboratory, best kept secret in the defense industry, by the way, and there's a reason for that. And then I went to Penn State Erie before I came here. I was the associate director of the engineering of engineering for research and tech transfer. So what I wanted to show you is just some of the things that I did along the way and highlight some of the things that can happen to you in a career. Okay. I also want to keep us on time. Okay, so at MIT, it was all about process physics. Remember I told you that I was a materials engineer? So I really got into the nuts and bolts of manufacturing. Okay? So at MIT, we became kind of obsessed with physics. You guys should be obsessed with physics, right? You're working in fundamentally a physics-related field. But what we were worried about was when you process advanced composites. Right? An advanced composite is a fiber-reinforced composite, the most popular aircraft materials, right? You really obsess about how much you can squeeze the fibers together in order to get higher mechanical properties, higher stiffness, potentially higher strength, okay? So we developed an analytical model. That's what they do at MIT. We developed an analytical model that described how bundles of fibers, how they behave in response to processing stresses in all of the different processes. So what you're seeing at the four corners there are like 4 popular ways of processing advanced composites, right? But it was a fundamental look, you know? We didn't concern ourselves too much with the details of the process. We just wanted to know, well, what kind of a load is being applied to the fibers as they're being processed? And can we, on the basis of physics then, understand how the fibers are essentially going to push themselves together under the influence of the processing stress? Fascinating stuff, okay? And then at Northrop Grumman, I got obsessed with the whole idea of taking cost out of processes, okay? And by the way, this is something that you're likely to encounter in your career, okay? One experience I've never had in my now long career is have a boss come to me and say, Greg, I need you to solve this problem. Spend as much money as you want. That's probably not going to happen. It's more likely that somebody will get you to look at a process or a product design and say, how can I take cost out of that? Because cost is really a key component of how well you and your company is going to be able to compete. So at Northrop Grumman, I focused on one particular part that's called the aft dorsal cover of the F-18, okay? And we came up with an automated way of making that part. The way that it's made right now, you will laugh at me, the way that most advanced composite parts are made right now looks an awful lot like the textile industry, okay? You cut out sheets of material and then you torture it layer by layer by layer over a mold, okay? What you would see on most aerospace production floors is a whole bunch of people running around in tennis shoes and white coats, basically trying to force these materials into complex contours. We had the simple idea of, instead of doing that, just lay them all together on the flat, which is easy, and then use something, in our case, an elastic diaphragm to force all of that material around the shape at one time. So you take out all of that labour that would have been involved in laying down layer by layer. And the net result was, we got about 50% cost savings on that part, which means now, if you happen to look at an F-18, if you happen to be around when an F-18 is flying in the sky, there are about 25 part numbers on that F-18 that were made by the process that we developed at Northrop Grumman when I was involved in that. Okay, actually I was the lead. Okay, there's no sense me being, humble about this. I'm really darn proud of this. Okay. Another thing that I'm really darn proud of is when I was at Penn State University Park, we worked on developing a left ventricular assist device. Okay, so this is a device that helps people who have serious heart conditions and they need to be operated on. Okay, but the operation is dangerous to that person's life. Okay, so what this does, follow me on this one. Okay, this does really sound crazy. So the way it works is they cut an incision in the femoral artery, which is right down here, the femoral artery, and they push through that incision a cable, right, that snakes all the way up into your ascending aorta. That's the biggest vessel that goes into the heart, and then a catheter, right, basically a cannula, sits across the tricuspid valve. Does everybody know what the tricuspid valve is? Hands up. Tricuspid valve is the valve that separates the upper chambers of your heart from the lower chambers of your heart, right? And it's a tissue valve, right? So this thing sits across that valve, and I kid you not, from outside your body, the cable is driven at 30,000 revolutions per minute, and it pumps the blood across the tricuspid valve, right? And thereby takes the load off of your heart. It can pump at about 5 liters per minute, which is roughly what is necessary to sustain life, And so this got European approval. It's in FDA trials in the United States. There is a delay because there was a problem with the drive system outside the body, actually nothing that we at Penn State had anything to do with. And we're expecting the trials to start up again maybe later this year. Bottom line is, it saved a lot of lives. But the other thing I wanted to point out, and this is really the important thing for me to say to you guys, is that that was done by a massive team, including electrical engineers, computer engineers, software engineers, hydrodynamicists, structural designers, materials engineers, and manufacturing engineers. So this is actually the core of the team that made that device, okay? Let me tell you this, guys, if you get involved with a project like this, and there's every possibility that you could, maybe not exactly like this, but a similar challenging project, you're going to have more fun than you could possibly imagine, right? You will not be able to wait to get out of bed in the morning to go into work because number one, the work is so exciting. It's so interesting. You get to work with so many different people and so many different disciplines. And when you're done, the sense of satisfaction is absolutely overwhelming. This is a still, that image in the middle, that image is a still from a procedure that was carried out in the Netherlands, which was when they were going through clinical trials in Europe, right? And I have the video, okay? 54-year-old man, which is exactly how old I am right now, who had a potentially fatal heart condition. He's wide awake while they're operating on him, wide awake. But they don't have to crack his chest open because they can snake this device in and other devices through the arteries in his body, okay? I'm not at all ashamed to say that when they sent me that video and I watched it, I broke down. I actually started crying because this little piece of work that I did, it was a lot of work, okay? But my small part of that was keeping people alive, okay? That's a wonderfully satisfying thing to actually know, okay? And what I'm here is to encourage you that you can get involved in projects that can really make a difference in other people's lives. And here's another one that I'm kind of proud of, and I'll go through this a little bit more quickly. I want to run out of time here, but so this is a project that we did for the Navy. And the idea was to design a material that could absorb blast energy, right? So one of the biggest problems that our veterans have experienced coming back from Iraq and Afghanistan and other theaters of operation is that they're exposed to blast energy, IEDs, okay? So what this program was, again, involving engineers of so many different disciplines, several different disciplines, materials engineers, structural analysts, testing experts, all of that type of thing, and computational fluid dynamicists, bringing them all together in a multidisciplinary team to solve this really important problem. By the way, the next stage of this, we were looking at before I left Penn State is, could you use this same materials development technology for sports helmets, football, hockey, high impact sport, okay? And then other things I go through really quickly here is, as you go through a career like that, you also get an opportunity to do some extracurricular stuff. So when I was at Penn State Erie, we worked a lot on entrepreneurship and innovation, right? And trying to create an environment where people who have ideas, maybe as some of you guys, have ideas for new businesses to support them through the nascent stage. We're really lucky here in Youngstown that we have the YBI, the Youngstown Business Incubator, which by the way is one of the best, if not the best, university affiliated incubators on planet Earth, and has been rated so on one occasion. And then the other thing is, in my spare time, I also got involved in hosting design workshops for people who are interested in product design. So to kind of bring this all together, in my view, experiential learning, which is a process you've just been through in your capstone, that's really just another name for a successful career. You're going to be doing this a lot. You're going to be working with teams. You're going to be interacting with teams of other disciplines, okay? I could just say it's also another name for a happy career. And that's my definition of a successful career, one that you're happy, right? It's possible, guys, okay? You could have it all. You could have a job that you're excited about, and that supports a personal life that you enjoy, okay? You've been given the tools, trust me. Trust me, you've been given the tools by this program. I think interdisciplinary projects are a fact of life, but they're a ton of fun. They really are, right? And what I see is a trend in industry to require broader knowledge of students. Gone are the days where you can only solve Kirchhoff's equations and Ohm's equations. I have no idea what I'm talking about here. Now your career is necessarily going to impinge on other disciplines. One thing leads to another, another, and another. Keep your eyes open, okay? Anything can happen. Did I believe when I was 7 years old, standing outside that thatched cottage with no indoor toilet, no running water, when nature calls, you went out to the elements? That photograph was actually taken from outside an outhouse. Does anybody know what an outhouse is? Yes. Right? Okay. Did I believe at that time that I would ever be the principal engineer at Northrop Grumman? Did I ever believe that I would be a consortium director at the Massachusetts Institute of Technology? No. The limit of my ambitions was I was maybe going to get a high school diploma. I was probably going to marry the girl down the road, and I was going to work in the bank. Not that there's anything wrong with that. There's absolutely nothing wrong with that. There was nothing wrong with the bank, and trust me, there was nothing wrong with the girl down the road either. Okay? But I'm here because one thing can actually lead to another. The other thing is always move forward. If you aren't moving forward, you're necessarily sliding backwards. There is a law in business, by the way, that a company that isn't growing is actually going out of business. Okay? So what that means to you is you keep moving forward, keep acquiring skills. The education starts now, by the way. I don't know if anybody's ever said that to you, but your education is now ready to start. You've been given the tools to educate yourself, and that's one of the most powerful things that anybody can do for you. Okay? So that's it. I mean, that's the story. That's my life story. It doesn't have anything to do with electrical or computer engineering, but yes, it does, right? Because I've worked with those types of disciplines throughout my career, right? This is an exciting time, guys. I'm in a wonderful position. I'm very happy with my career. I really am happy to be at Youngstown State University, but yet despite all of that, and despite the experience I had, and I'm jealous of you guys. This really is a kind of a golden time. If you want to get in touch with me, please use this contact information. If there's any way that I can help you, I'd be more than happy to. And thanks for your attention. It seemed to me like I had most people's attention. Okay? So thank you so much.